Hi, at Twingate, we're looking to provide a lightweight approach to implementing zero trust as we move away from physical networks being the center of gravity to more of a model where user identity, device trust, and context are incorporated into securing remote access.
Hello, everybody, and welcome to today's webinar presentation, the Top 5 VPN Challenges, brought to you by Twingate. I'd like to introduce you to our presenter, Alex Marshall. Alex is the co-founder and chief product officer of Twingate. And with that, I would like to pass it off to Alex.
All right, thank you. Well, nice to, good morning, everybody, and I'm excited to go through this presentation with you. So my background, I've spent about the last 15 years in the B2B software space, and one of the things that I've noticed is that the best technology doesn't always win, right? So what tends to work really well is that a technology that solves customers' problems, but also is relatively simple and easy to deploy and manage. And that tends to be really, really important in the B2B space. So at Twingate, our mission is to make working for anywhere simple and secure. And in doing a lot of research for the founding of Twingate, we learned a lot about VPNs, and which is really the dominant sort of remote access technology today. And what we wanted to do today is to share with you sort of what we learned. So with that, we'll get right into it. Okay, so let's talk a little bit why this is sort of important up front. I think the big thing is that VPNs are fairly outdated at this point. So they're a technology that really came to the forefront in the 1990s. And the problem that they were solving, at that point in time was not allowing a user to gain access to a resource in a remote network. It was actually joining two networks. So VPNs were designed from the get-go to connect a satellite office back to headquarters. And the purpose was really to allow every device, every machine on one network to access every machine on the other network. So you had like one big network. So we'll come back to that in a bit, but that's a fairly big problem in terms of securing VPNs these days. Second is like the workforce is changing. Again, in the VPN world, it used to be that everyone came into the office. They weren't able to take their desktop computer home with them, and so these days you have people that work from all different kinds of locations, at home, in the office, coffee shops, and they use lots of different devices. And on to the third point, the resources they're accessing are distributed as well. So you really have like a completely different model now for how people work and how companies organize information than you did when VPNs were really introduced. So on that sort of broader context, security risks are increasing, and a lot of this is because of just how distributed everything is now that you have resources on the internet, on private networks, on public clouds, private clouds. You have resources everywhere. As it's actually become there's a lot bigger overhead in actually securing all of that. And the risks are higher because it's simply much more difficult to secure something when you have a much broader surface area than you did before. And then the last couple things I think that we really noticed is that security really needs context. I think that the sort of like the dominant approach has really been making sure that every single packet is inspected. You have a bunch of really detailed firewall rules, and all that works fine, but it's fairly brittle, and one omission or one small mistake can actually lead to a pretty serious incident. And so having like context for that security really helps, because then it allows you to determine when you need to apply certain security controls and when you don't, right? So let's sort of like focus your security needs. And we'll come back to this a little later on, but there really are like a lot of like really great solutions that exist today. We of course have one, but there are many solutions out in the market that take a very different approach and are really great alternatives to VPN. Okay, so let's sort of go into the top 5 challenges I think that we see and that what we've heard from customers and prospects and people that we've talked to. So the biggest one, I think, in our mind and what we've seen is that the way the VPN works, if you want to allow someone outside your network to access your network, is you have to have a VPN gateway that is exposed on the public internet. So it has a public address, which means that anybody in the world, friend or foe, can access that VPN gateway. And that has like obvious security implications, which we'll talk about later on. The second one, which I think comes part and parcel with the way the VPN works in terms of joining two networks, is that if an attacker is able to gain access to your network using VPN as an entry vector, they have the ability to move around inside that network pretty broadly. Again, because VPN was designed to give access to broad networks, not to individual resources. Third is performance. So again, going back to the inception of VPN, right? VPN was designed to connect two networks. And so what that means is that it sets up a tunnel between these two networks where every single packet goes through that tunnel without any real optimization around how that happens, right? That's really how it works, and that's how it worked back in the 90s, and that's how it still works. It's difficult to reconfigure. So VPN, certainly you can set up multiple VPN gateways, but it's fairly difficult to do it in a dynamic way that allows you to reconfigure things like as your needs change, right? So whether that means bandwidth or different, different networks you're setting up, or employees working in different places. And that really goes, I think, to the overarching issue here, which is that managing all of this requires, a ton of support maintenance over time. And that was one of the really big things that we hear from people that we talk to. Okay, so let's go through these in a little bit more detail. So just as a reference point, so when we're thinking about, what does a VPN look like today? This isn't the only model that exists, but this is a very, very common model. And so that model is that you generally have some kind of central corporate network, and that's the corporate network that employees, access when they're in the office. And because all access is generally centered around people being in the office, and again, this is changing, we'll talk about that, but the sort of legacy sort of configuration here is that access relates to someone badging into an office and then accessing things from that office. And where VPNs have really been deployed, especially over the last 20 years, is as entry points into the corporate office, because the thinking was, if we had people in the office and they go home, well, we really want them to appear as though they're in an office from an access and security standpoint. So what that means is that really, regardless of what team you're on, if you need access to some kind of internal resource, regardless of which network it's on, which here we have some examples of public clouds as well as SaaS resources, very often the solution that the companies give their employees is access a VPN that gateway is on one network, and then traffic is whitelisted between those networks. And so that's really what we're representing here, as a sort of like bottleneck where a bunch of traffic is flowing through. I think we're aware that there are many different ways to set this up, but there is a limitation here in terms of like how many different VPN gateways you can set up because of the overhead on the end user, because they have to select one particular VPN gateway. They can't connect to multiple at the same time. So when we're talking about some of the VPN challenges, like this is really sort of like the reference architecture that we're talking about that really resonates with our customers and our prospects. Okay, so let's dig into this a little bit more. So going back to that first challenge about being exposed on the internet, this really, I think, this is like from our standpoint, from a security standpoint, really like the biggest issue with VPNs. The argument, I think, can be made that VPN gateways are hardened. They perform a very specific task, right? There's a lot of effort put into securing them, but I think, as we all know, software is fallible, and at the end of the day, systems are compromised, and we'll talk about that more specifically in a second. But we doing some research on this, I think, and again, this resonates with what we're hearing from our customers, is that really, like, VPN gateways, despite all the effort that's put into securing them, is that they're one of the most common entry points for ransomware attacks after RDP, which suffers from similar issues. The other thing is that because they're public and they respond in a particular way, they're actually very easily discoverable. And so any one of you that's listening, right now, you can actually go to website showdown.io. It's on the slide here, and you can actually just search for VPN gateways, and you'll see that there are hundreds of thousands of them available, and this is a public search index. And so you can imagine that if I'm an attacker looking for an easy entry point, all I need to do is wait for a vulnerability to be discovered on a VPN gateway, or discover one myself, and then methodically go around the internet and then compromise every single one of those. And so that is, in fact, exactly what happens. So I think we've probably all heard of these recent attacks. Colonial Pipeline was more recent. Travelex is a few years back. But looking into the details as to what happened in these is that it's actually pretty, you know, maybe it's not surprising. Actually, I was gonna say it was surprising, but it's probably not surprising that actually both of the entry points for both of these attacks was a VPN gateway. So they're a little bit different in that the Colonial attack wasn't due to a vulnerability being found in the VPN gateway, but it was actually because credentials were compromised. And so this is, of course, part of a broader problem in not, deprovisioning accounts and leaving those accounts active. But I think there's a two-part thing here. So with Colonial, being able to discover an account that was still active, there's part of a, just like a general like IT governance issue there in terms of like making sure that accounts are deprovisioned. But the other problem is that, if the VPN gateway is publicly available, there are alternative ways to set this up with alternative technologies where that gateway isn't available. So even if the credentials are somehow still in possession of somebody or an attacker, it's much more difficult to gain access. Travelex is a different situation. So in this case, it wasn't a credential issue. It was the fact that there was a known vulnerability from one of the VPN vendors, and attackers in the Travelex case simply looked for that vulnerability. And so they looked for a particular version of the VPN that hadn't yet been updated, and that's how they were able to get access into Travelex. So, needless to say, like this is, a problem that affects, any company that I think is using VPN for access. It's also incredibly expensive. So the costs we have listed on the slide are really only the costs that were paid out to the ransomware hackers. In Travelex's case, they actually filed for bankruptcy as part of this process. So it really is a really major issue. Okay, so part of this, and I think this is part of the attacks we just talked about, is that because VPN is designed to give a user access to an entire network, there's VPNs, usually it's almost always a subnet that you're giving access to, and a lot of times people just for ease of gaining access to internal resources, really just give access to the entire network that's available on the far end. But even so, like the default access method is access to a subnet. And what that means is that even though you're just providing a VPN for your employees gain access to, probably for most of them, just a few resources, it does mean that many others are available. And so this is prominent in the Travelex attack and in many others, is that attackers will come in via the VPN as a vector and then sit undetected for as long as possible and then move around on internal resources. And this is a very, very, very common attack method. And so if you're looking to avoid this type of attack and deter folks, VPN really doesn't cut it, right? It's really difficult with VPN to give very, very granular access permissions to individual users to only exactly what they need, simply because the technology wasn't designed to do that in the first place. And so the problem here is that people sit in there internally, they just look at all activity that's happening, and they can be very, very good at just remaining undetected for a long time. And so as we were doing research around this, I think we're actually pretty surprised to find that many breaches go undetected for a long time. 212 days is a long time. It's the better part of a year, right? And so they can do a significant amount of damage. Okay, we talked about this a little bit earlier in terms of performance with VPNs, in terms of that VPN sort of being a bottleneck in configuration. I think that there's really a couple things here. So I think the main sort of thing that we're showing on the slide here is really like a routing issue. So again, because like the root problem here is because it's relatively maybe not difficult, but sort of configuration-wise more painful to set up many VPN gateways to give access to specific networks, specific subnets within those networks. Most companies try to minimize the number of VPNs because that minimizes the overhead of having to explain to employees like which particular VPN gateway they need to connect to in order to get access to particular resources. And so the architectures that tend to result from the deployment of VPN tend to result in a few problems. Like number one is bottlenecks like you see in the diagram here, where all traffic is routed through a particular central network, and that traffic is then routed to additional networks. The other problem is that sort of inherent in that bottleneck is this concept of sort of backhauling, right? So in this diagram, we're not showing the geography of this, but let's say that the corporate network is on the New York City, the user is in California, and the AWS VPC that they're trying to get access to is in Oregon. Well, what the worst case scenario here is that user then through this VPN configuration needs to connect through New York to access the VPN through that corporate network, and their traffic is routed back to Oregon, which is clearly a much longer route than would be taken if the user could connect directly to that VPC that's in Oregon. So backhauling is an issue. The bottleneck is an issue in terms of just concentrating a bunch of traffic through one entry point, and also then having to manage that traffic as it flows through the corporate network, which is probably not really the intent and the goal of managing that network. The last thing I think that's inherent here is that there are, of course, a couple different ways to set up VPNs. There's a split tunnel method and a full tunnel method. Very often, companies are using full tunnel because they're also trying to ensure that all the same sort of security rules and firewall rules and everything are applied to that traffic when the user's outside the office as when they're in the office. And so that full tunnel method means that traffic that doesn't even need to go through the VPN ends up going through the VPN. So a good example is web video conferencing calls like Zoom, and that traffic really doesn't need to be backhauled through that VPN and out to the internet. It really should just skip it. And then the last issue here is that VPNs really don't do any sort of level of any connection level performance management, right? So the VPN is this tunnel that just takes every packet that shows up, encapsulates it, and delivers it at the other end. It's not aware of different connections and their ways you can optimize the traffic flow for each individual connection to different resources on the other end. So all in all, VPNs tend to be a fairly negative experience from a performance standpoint, even if they sort of get the job done. Okay, number 4, I think, is really a combination of sort of inflexibility of VPN architecture, but also the fact that workforces are organized very, very differently than they were at the inception of this model. So a couple big things. One is this idea of sort of hybrid workforces where people are in different locations and different roles that often need very different access requirements are very typical these days. And there's also a ton of device environment diversity. And so both of these are present challenges when you're managing sort of existing VPN deployments. So just go into this in a little more detail. So virtually every business that we work with and we talk to has some combination of full-time employees, part-time employees, contractors they work with, often partners, not necessarily contractors, but partners that they're working with that need access to internal systems. And managing access for all these folks can be really, really challenging, especially when there's some combination, as we'll talk about environment diversity in a second, some combination between SaaS applications that these users need access and private applications, which could be either on-prem or in a public cloud system, but are otherwise sort of off the public internet. And so, of course, it goes without saying that over the last 18 months, most folks working in offices have started working from home now. So that's just introduced additional strain into this model. And so the second thing is really around sort of device and environment diversity. It's long gone are the days where everybody had a machine that sat in the office. Now, usually the model that we're seeing is that there's really sort of 3 levels of devices. One is a company issued laptop, so usually Mac, Windows, and sometimes Linux. And then I think companies have largely shied away from issuing sort of corporate phones, and so you almost by default have to have a BYOD policy for folks mobile devices, and they just have different set of requirements that need to be applied to them. And then the third one is really guests, right? So you still have guests that need to access the network, whether they're everything from an interview candidate to a contractor to a partner, like we were talking about before. And so this diversity in terms of the number of devices or the diversity of devices that are coming onto your network and that need to access different sets of resources presents a challenge in terms of how you address what the security requirements should be for each of those different categories, and how they should be different for each type of individual that's using that device. So this presents us a lot of problems with VPN, and VPN tends to really only give you this option of you're either on or off, which doesn't really give the level of flexibility that actually matches what the reality is today. Okay. So the last thing that I think, as I mentioned earlier, really sort of covers almost everything here is there's just a ton of overhead and maintenance that's required to manage all these things. And so what I wanted to share with you is just like a little bit, just a very brief case study that I'm sure resonate with a lot of you. Which is, we were working with, a company that's a customer of ours now, and their situation was as soon as the pandemic started and everybody, had to work from home, all of a sudden I think they realized like how deficient like their existing like VPN solution was. So they had an on-prem VPN that, as they say, was like bursting at the seams, which I think sort of like a great visual, but I think you can imagine with probably a small percentage of the overall workforce using their VPN to all of a sudden 100% of the workforce using the VPN. They went through a very, very painful period of time where they had to scramble to essentially get additional hardware in place, figure out how they were going to ensure that they moved to like a split tunnel model and so on, just to reduce bandwidth. And then there's just a bunch of sort of headaches they had to deal with. Not anything that anybody was enjoying doing in the early months of the pandemic. And so I think what this made them realize is that this model or the solution, the existing VPN solution, really doesn't work, for the world that we live in now. And even I think as we move maybe towards more of a hybrid, in-office work from home model, this is still a major issue for people. And so it's really, the pandemic has really been a wake-up call to them that this remote access infrastructure really doesn't actually work very well. So from their standpoint, moving to a solution like ours, but I would say like any zero trust solution, is that they really save like a huge amount of time. And there's really been, I think, few like major differences they've seen. Like first is pure time saving from an IT standpoint of not having to work with individual employees, like work through problems they're having, getting a VPN deployed on devices that probably weren't deployed on before. And really just like a huge amount of time like working through problems with the customer. So that's largely gone away. Bandwidth is no longer an issue for them. As we'll talk about in a second, I think there's this sort of more modern like zero trust model allows really like point-to-point connections. So you remove the VPN as that bottleneck. But really one of the biggest things that they've been able to do is actually build in the zero trust access model into their infrastructure. So they now sort of have this deployed programmatically using infrastructure as code directly into their infrastructure. It just means that really they don't have to spend a ton of time that they're spending before maintaining and ensuring that the system's up and running and performing. Okay, so that wraps up, I think, some of the major challenges that we see and we hear around VPN. And so what I talk about is this general model of zero trust and how it addresses some of the things that we've talked about. So I just want to reiterate. I mean, we talked about this a little bit earlier in terms of the fact that the way people work has changed and all that has really shifted. But just to sort of like reemphasize, I think the differences is that, again, the old model, which is now at this point several decades out of date, but maybe was still in place before the pandemic, has really been blown up, is one location or at least a physical location where people work. That physical location, by being on that network, acts as this sort of proxy for the fact that you are an authorized individual that can access internal resources. So the parallel we draw is a little bit like physical security, right? If you're in the building, you can badge in, then you have access to stuff, right? So it's a fairly permissive model. And again, like using VPN to gain remote access to things. So the assumption there, the core assumption, is that everything is in one place, and that by being in that one place, you're entitled to access those resources. And really the new model, which is like the reality I think that we're all living in, is that everything is distributed by default, right? So people are everywhere, they use many different devices, their resources are distributed all over the world, different teams work together on different things at different times, and so those access permissions are really shifting all the time. And so, over the last, 10 years, there's been this like growing awareness around this model of zero trust and this idea of giving people the least amount of privilege that they need to address like some of the issues that we've talked about before. And key to all this is ensuring, of course, and in doing all of this, is that you keep those rules up to date and you find ways to sort of automate that and pay attention to context automatically where you can. So just to sort of redraw that diagram that we had earlier that showed some of the sort of limitations of the VPN, this is the same model. So it's the same two devices for two different teams accessing, three networks and two applications. And the model, I think, has some pretty significant differences, right, which I'll go through. So first of all, going back to that number one issue that we raised, there's no public attack surface in this model, right? So the connector, and I guess to be specific, that there's no public attack surface for your network. You can essentially make any network you have completely invisible. And so what we're highlighting here, and this is using our own terminology, but this is common to many zero trust products, is that the connector, which is the software component that allows access into those networks, is we're having the diagram here as being behind the firewall. And so with that connector being behind the firewall, you of course should do everything you can to secure the connector, but the burden is much lower, and there's no inbound ports that need to be open, anything like that. So your network can be completely invisible from the internet. So that removes right off the top, pretty significant attack vector for people just scanning public ports. Second thing is that you'll notice that like everything is really sort of point to point. So if you need to access something in a given VPC or one of the SaaS applications, like your connections are going to go directly to that destination as opposed to being routed through some central bottleneck. Thirdly is there's this concept of sort of like least privilege access. So in the example here, the user that is on the engineering team, they have access to all three of the private networks, the corporate network, AWS, and GCP. But what we've shown is that they actually only have access to a subset of those resources. So for example, in GCP, they only have access to Tableau and not this IP address defined resource. And that's intentional, right? So by default, you don't want people to have access to everything. You want by default people to have access to nothing and have resource access be positively granted, right, as opposed to trying to do the opposite. The next part of this is that the experience is pretty different. So when you have a model like this, what your user experience is that on their device, so when they're doing their work on their laptop or their desktop, they're going to do everything that they did before, right? So they're still going to access applications in exactly the same way, whether that's using SSH or remote desktop or a database client or a web-based application. Everything works exactly as it worked before, but now they no longer as a user have to decide which network they're connecting to, which is really a core part of that VPN experience. You choose a network, you connect to it, you do your thing. If you need to switch networks, then you need to do that manually. So in this model, you abstract away the physical network, which is something that the user really doesn't need to know about anyway, and you give them access to individual resources with particular addresses. And so now what you have is you have a model where a user, given their role or some particularities about their needs, is really given access to things based on an address, not based on an entire network. So you've really immediately scoped down what they're able to do, which reduces your sort of internal attack surface. And the last thing is that this model really reflects how we work, right? So we have people in lots of different locations accessing resources in lots of different locations on many different types of devices, and so that's really, I think, what's key to all this, is that this model was actually built for the reality of how people work today, not the old VPN model, which is built for really a scenario that doesn't really apply to the end user. So okay, so let's just summarize this in terms of before and after. So yeah, just to reiterate, VPNs expose the public internet. Instead, if you're looking for a solution in the zero trust space, what you should be looking for is, any type of solution that hides those entry points and puts them off of the public internet, right? I think this day and age and the amount of attacks that happen so regularly, really nothing should be on the public internet. So that really is like a fundamental requirement. We talked a lot about attack surface and lateral movement. So really, what you should be looking for from a zero trust solution is, as I emphasized before, applying access at a resource level. So an individual, due to their role or group in the organization, should have access to resources based on the address of the resource, not based on the network that they belong to, and that access should be controlled over time, right? So another sort of issue that happens is that once someone's given access to something, that access is rarely taken away. Well, with some of these more modern solutions, you can actually trim that access over time if it goes unused, so that you minimize that sort of attack surface area as much as possible on an ongoing basis. From a performance standpoint, of course you can bottleneck things if you want to, but you certainly don't have to with a point-to-point zero trust solution. So the idea is that you build your network infrastructure as you need to from a security standpoint, or whatever makes sense from the standpoint of laying out your applications, and that you layer on the access solution. The access solution doesn't dictate the architecture, right? That's really important. So with modern zero trust solution, you should be able to deploy those entry points into the networks as needed, without having to reconfigure your network architecture overall. And that really speaks to, I think, actually the fourth point as well, which is that ease of sort of reconfiguration. Most, or probably every zero trust solution I know about today is completely software based, and many of them, ours included, have direct integrations with infrastructure as code, applications such as Terraform. Right? And so that makes it way, way, way easier to reconfigure access as needed based on infrastructure changes. And the last thing I think, again, as I said before, sort of like overarches all of this, is just making it easier to support and maintain a solution makes a massive difference. And what we see is there's really sort of three major stakeholders. There's the end user, and I think that improving the end user experience really makes a big difference, because a lot of the challenge with security is adoption. And so if you make it difficult for an end user to take certain actions which the company wants to maintain security, then you're going to get relatively poor compliance, or if you get compliance, you get a lot of complaints, which sort of defeats the whole purpose of deploying something like that. So you want something that's really easy to use, that really sits in the background, that users really enjoy, and makes their work life easier. And if you do that, you'll get great adoption of the security solution. And then the second stakeholder is IT, and so integrating everything in, looking for a solution to integrate sort of like user and group, sync back from companies' identity providers and so on, just minimizes maintenance. And then on the DevOps side or network engineering side, is looking for a solution that is very easy to deploy into infrastructure as needed and as an infrastructure changes. Okay, so that wraps up the main portion of what we wanted to share today on those top challenges. I did want to spend just a little bit of time at the end here, and then we'll take some questions, just talking about a little bit more about who we are at Twingate. So this is our team. There's three co-founders. Really, I think what our passion is really finding elegant solutions to thorny problems. And I think especially all of us have a ton of experience in the B2B space. Really, I think what we're super passionate about is, in the network security space, like we just haven't seen a lot of solutions that really emphasize, ease of use alongside strong security, and that combination is really powerful, right? If you can find something that's easier to use and more secure, that is really like a very strong win for people. And so we've really, really internally put very strong emphasis on making sure that our product is easy to deploy and easy to manage, and is a pleasure to use for people internally. And if you do those things, especially in a space like network security and in the zero trust market, then we believe that we've got a winning product that really serves our customers very well. And speaking of our customers, they're all over the place, right? So many different customers of different sizes, but they all really have this like sort of common problem, which is that they dealt with a lot of the things that we talked about earlier in terms of those major challenges with VPN. And what they were looking for is some kind of solution that would scale with them and fit into their existing um, sort of existing model and how they wanted to see their sort of network, their sort of remote access model, and then their network architecture change over time, right? So I think they're all really, I think, very bought into this idea that yeah, the world has really significantly changed, and so that means that remote access, needs a different approach too. Okay, so thanks very much. I think we'll take a few questions. So just take a look and see what's come in here. All right. So yeah, so I think one of the questions here is talking about, I guess the question is like, how difficult is it to move from a VPN to zero trust solution? And again, I think I guess it goes off sort of my last point there. The you know what we've seen from the very beginning is that as we were doing some initial research on the company is that one of the biggest things, sort of complaints I guess that we heard was that people complained about VPN, but they also were aware that zero trust existed as a concept, but they had not seen a zero trust product that was easy to deploy. And just as an example, like some of the existing solutions, required 30, 40 page of instructions to get up and running. And so that was like we saw that as an opportunity. And so I think this whole process of change management, how do you move from one solution to the existing solution, is something that we've really been like very focused on. And so I think a lot of what's sort of one of our customers and what we've seen like really resonates with the market is, for an initial proof of concept, like you can truly set up our product within 15 minutes. And I think that starting point allows customers to see like how they can integrate the product into the rest of their sort of network infrastructure, and then shows them sort of like the path forward on that. And so I think there's a couple of key things. Like one is, as I mentioned before, we've sort of integrated with a bunch of tools that allow to automate the deployment of our product into customers' networks. That reduces just a ton of manual overhead and reuses existing processes for them. The other thing I think that's really important is that as part of deploying, product, I think you should really be looking at how much change is required from the end user standpoint. And one of the sort of, I think negatives that we've seen is you should really look at, do users have to start accessing the same resources they're accessing today using different addresses? And I think if that's the case, then companies are really going to have a really tough time. Usually have a really tough time, I think, making that transition, because now you have to go to every single employee and sort of rework their workflows. So I think that a lot of that is like looking at, can users access resources exactly the same way they're accessing them today with the new solution? And I think if you can find that combination of things, then I think you're in fairly good shape. So there's still a range of solutions out there, but we think we really focus on make it very easy. I think the other question here sort of like related to that is, I guess it's more asking about our solution here, but sort of like, do we have to question is, do I have to disable my VPN infrastructure before I can use TwinGate or a product like it? I think in our situation, for our product, like that's not a requirement. So you can run these things sort of side by side, and usually what we're seeing with our customers is that they're moving teams over to the new product, TwinGate ideally, from the existing product. And doing that team by team, and so you don't have to sort of do this like big switch. But we have had customers that basically said, we've got in the next 72 hours, we're going to switch over to TwinGate. We believe we've given access to everybody to the things that they are authorized to access, and they've really just done that switch over in a few days, and that's also worked fairly well for folks. But again, I would go back to some of those fundamental questions. But do users have to change anything that they're doing, or can they just use a new product with no changes to addresses, no changes to special proxies or other configurations? And then can that product be easily integrated into the existing infrastructure? Okay. And then, I think we just have like one more question here, which is a question about sort of integration with existing security stacks. So the question is, how does TwinGate integrate with my existing security stack? So I think the question here is around sort of like DLP and secure web gateways and that kind of thing. And so the really, I think the way that we've designed our product, and again, like, can't speak for everything in the market, but there's a lot of variation. But I think that the approach that we've taken is that our product really operates at, the transport level, right? So what we're doing is we're managing TCP traffic, UDP traffic at, that low level, and we're not managing things on an application basis. And so what that means is that when we're moving traffic around for access to protected resources for users, is that, the vast majority of times, like, we're not interfering with anything else that's going on. And so the way that, we sort of coach our customers on this is that you can use our product alongside everything that you're using today, whether that's, at the network level or, deployed as an agent on the device. There's really no issue doing that. And that was, like, very intentional. We wanted to make sure that, for our particular product, you could deploy it into an existing environment with an existing set of controls, and not be super disruptive. And okay, so I think that's all the questions we have for today. So really appreciate you taking the time to listen, and I'll hand it back to D-Zone.
All right, and with that, D-Zone would like to thank Alex for an amazing presentation. D-Zone would also like to thank TwinGate for providing the audience with a great webinar. Lastly, thank you to everyone who tuned in. We hope you learned something new that will help you in your developer career.
If you'd like to try out TwinGate for free today, we'd love to have you join our Zero Trust journey. You can see the product in action live by signing up at twingate.com/signup. Thanks so much for your time, and hope to see some of you very soon.